Good morning, one and all. Myself, Mrs. Monica Samir Joshi from MIT College, Aurangabad, is going to give the idea about how to write an assembly language program for 8086 microprocessor, useful for third year UG students in Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. The learning objectives for this will be the student should be able to develop an assembly language programs using the instruction set of 8086 microprocessor. Student should be able to write algorithm for the same and can draw the flowchart for the same. The key concept for this are they should go through the instruction set, and for this video the arithmetic instructions are used. Already we had seen the data transfer instructions group from this 8086 instruction set. We'll recall the types of instructions for 8086 microprocessor: data transfer instructions, arithmetic instructions, bit manipulation instructions, program execution transfer instructions, string manipulation instructions, and processor control instructions. Today we are going to focus on the arithmetic instructions and build a assembly language program for the same. We'll go through the arithmetic instructions in brief with the syntax of the same. Add destination comma source. Addition instruction between two entities, either 8-bit or 16-bit, or two consecutive registers taken, the 32-bit comma taken. Add with carry, ADC destination with source, then subtract destination with source, and subtract with borrow the destination with source. Many a times an incrementation and decrementation is needed for any data, so this increment source or decrement source is there for the same. Then ASCII adjust after addition and decimal adjust after addition are there. Many a times in 8086 there is a provision for getting the result in ASCII format by use for all arithmetic types, that is addition, subtraction, multiplication and division. Only the difference is in all these are there after addition, subtraction and multiplication, but for only division it is before division the ASCII adjust is done. So AAA indicates ASCII adjust after addition. DAA already you had studied it in 8085 microprocessor, that is decimal adjust after addition. If you want the result in decimal, this instruction can be used. But in 8086 the provision is there, decimal adjust after subtraction is also there, which was not there in 8085 microprocessor. Then negate source. If you want 2's complement directly, you can get the 2's complement through this instruction. Negate the source. Then compare destination with source. The contents are compared. To result is stored. This is was comparison, that is greater than, less than or equal to. Then multiplication instruction, the syntax is only multiplication the source contents are there. Then IMUL source is integer multiplication is there. Likewise the division is also there, div and idiv source, that is division and integer division is there. For division, many a times a byte is to be converted to word. There should not be a 0 divided by 0 error, and for that purpose CBW and CWD two instructions are there. Convert a byte to word and convert a word to double word. Likewise, I had told you already about ASCII adjust. AAM stands for ASCII adjust after multiplication and AAD stands for ASCII adjust after division. So all students are requested to go through, already we had seen this, go through these instructions, because now we are going to develop the assembly language program for the same. This is the list for the arithmetic instructions. This is an algorithm about program to add two 8-bit numbers, number 1 and number 2, and store the addition at memory location result. This is the algorithm for the same. Start the data segment, define a byte by using the any assembler directives, that is DB, define byte with number 1, define a next byte with number 2 and define a byte as a result, because before doing the addition or any operation you don't know, so define a byte with named result or with the directive result. Then end the data segment. Once you enter the data, that is three things are needed for addition. one source, two sources, that is two operands, and one destination is needed. So 3 bytes in a memory are reserved for that, number 1, number 2, and a result. Then end the data segment. Then next is the start code segment. Assume the names of data and code segment. Whichever names you are going to assume through this statement throughout your program, you have to use this for code or data segment. The next is initialize the data segment, that is segment base is decided, because this is the beauty of the 8086 microprocessor, that is 1 megabyte memory can be used, a virtual memory can be used. So segment base is decided by the manufacturer, and at different times different segment base can be used. This is the beauty of the memory segmentation advantage of 8086 microprocessor. So before starting any operation, initialize the segment base, data segment base. Then move number 1 to AL. One of the this is accumulator base, so one of the operand is in the AL. So move the number 1 to BL. Any register can be taken or directly addition can be taken. Student can apply any logic for the same. Then use the instructions to add the two contents. Then move the AL content and end the start and end the code segment. Every time the segment should be end, because otherwise it will be considered as a syntax error. So this was all about the algorithm of how to write an assembly program for addition, subtraction, or any arithmetic instructions. This is a simple program to add two 8-bit contents. So how this can be implemented using emulator software, that we will see in the next class, and how to draw the flowchart for the same we will see in the next class. And the assignment for you all is write an assembly language program for 8-bit addition as well as 16-bit addition, and the result will be whatever the result will be stored on the memory location, result named as result, and submit the solution at my desk before coming to the class. And if you have any doubt, you can discuss among yourself and you can share it in a class. Thank you all.